Welcome to Flow Edge, where knowledge flows and you gain the edge. Welcome everyone. Today's lecture is on push and pull view in a supply chain. Let's explore how supply chains make decisions about production, inventory, and distribution, and how these decisions impact efficiency and responsiveness. To begin, it's important to understand that every supply chain aims to balance two key goals: cost efficiency and customer responsiveness. To explain how supply chains achieve this balance, we look at two fundamental perspectives: the push view and the pull view. These views describe how decisions are made regarding production, inventory, and distribution. To make this more relatable, think of it like cooking for a party. In the push view, you cook a lot of food assuming guests will come, and in the pull view, you cook only when the guests confirm that they are coming. This analogy helps us visualize how supply chains either anticipate demand or respond to it. Now, let's start with the push view. In this model, supply chain decisions are based on demand forecast rather than the actual orders. That means products are planned, produced, and moved in anticipation of future demand. Now, let's break down the key characteristics of this approach. First, production is forecast driven. Companies rely on historical data and market trends to estimate future demand and plan their operations accordingly. Second, inventory is built in advance of demand. Products are manufactured and stocked before customers place orders, ensuring availability when needed. Third, this model is suitable for products with stable demand such as everyday consumer goods, where consumption patterns remain relatively consistent. To illustrate this, consider these industry examples. In FMCG, like packaged snacks or toiletries, products are produced in bulk to meet the expected demand. In pharmaceuticals, medicines are manufactured ahead of time to ensure stock availability. And in the automobile industry, basic car models are produced in bulk based on expected sales trends and pushed to dealerships. Now, let's look at the advantages of the push view. One major benefit is economies of scale, which means producing in large quantities reduces the per unit cost and improves the operational efficiency. Another advantage is product availability. Goods are ready for customers, which is especially important in the markets with consistent demand. Finally, this model supports predictability, where industries with stable consumption patterns benefit from streamlined planning and resource allocation. However, the push view has its own drawbacks. A key disadvantage is the risk of excess or obsolete inventory. If forecasts are inaccurate, products may expire or become irrelevant. Additionally, the system offers reduced flexibility, wherein the companies may struggle to adapt quickly to sudden changes in customer preferences or the market conditions. Lastly, higher holding cost can be a concern. The unsold inventory requires storage, insurance, and ties up capital that could be used elsewhere. Now, let's move to the pull view. In this model, supply chain decisions are based on actual customer demand. Products are manufactured or distributed only after orders are received. Let's explore the key characteristics of this approach. First, production is demand driven. Companies wait for customer orders before starting production, which helps reduce waste. Second, there is minimal or no finished goods inventory. Since the products are made to order, there is little need for storage. Third, the system is designed to respond quickly. It's built to react fast to customer needs and market changes. And finally, it's suitable for variable demand, ideal for industries where trends shift rapidly or customization is essential. Here are some examples of industries that use the pull view. In the fashion and apparel industry, designs are created based on the current demand trends. In electronics, products are assembled or configured only after the orders are received, like built to order laptops. Similarly, in the customized products, such as gaming PCs, production begins only after order confirmation. Now, let's look at the advantages of the pull view. First, it leads to lower inventory cost. Less stock means reduced storage and handling expenses. Second, it reduces the risk of unsold stock. The products are made only when needed, minimizing waste. Third, it allows for flexibility and customization, wherein companies can tailor products to individual customer preferences, enhancing satisfaction. But like the push view, the pull view also has its limitations. One challenge is higher production or transportation cost. Small batch sizes can be less efficient and more expensive. Another risk is stockouts. If demand spikes unexpectedly, companies may not be able to fulfill orders quickly. Lastly, the pull model depends heavily on infrastructure. Its success requires fast, reliable systems and suppliers. Well, of course, many industries don't rely solely on one model. They combine both push and pull approaches to optimize performance. Here's how it works. Push is used for initial stages such as producing standard components or raw materials in bulk. Pull is applied in the later stages like final assembly or customization based on actual demand. For example, in fashion, basic t-shirts are produced in bulk using the push logic, while trendy or seasonal designs are made on actual demand basis using the pull logic. To summarize the comparison, let's look at the key differences between the push and pull views. Firstly, on the basis of planning, in a push system, planning is based on forecast, wherein companies predict future demand and produce accordingly. In contrast, a pull system relies on actual customer orders, meaning production only begins when demand is confirmed. When it comes to inventory levels, push model maintains high inventory levels because goods are produced in advance and stored until sold. Whereas the pull model, on the other hand, keeps inventory low or even non existent as products are made only after receiving orders. Third is responsiveness. Push systems are less responsive to sudden changes in customer preferences or market trends since production is pre planned, whereas pull systems are highly responsive, allowing companies to quickly adapt to real time demand and customize offerings. When it comes to cost efficiency, the push systems benefit from economies of scale, wherein the bulk production reduces the per unit cost and improves efficiency. On the other hand, the pull systems may have higher operational cost due to smaller batch sizes and more frequent adjustments. The fifth point of comparison would be risk exposure. The push models carry the risk of excess or obsolete inventory if forecasts are inaccurate, leading to waste and higher holding cost. On the other hand, the pull model faces the risk of stockouts or unmet demand during sudden spikes, especially if the infrastructure isn't fast or flexible enough. Lastly, when we compare them on the basis of industry suitability, industries like FMCG, pharmaceuticals, and automobiles typically use push systems due to the stable demand and need for availability. On the other hand, industries such as fashion, electronics, and customized products prefer pull systems to stay agile and meet the dynamic customer needs. As we can see, push is efficient but less responsive. Pull is flexible but riskier without stronger systems. And the hybrid model offers a balanced approach. Thus, to give it a closing thought, the push view is best for efficiency and predictability, whereas the pull view excels in responsiveness and flexibility, and the hybrid view helps balance both efficiency and customer satisfaction. By understanding these models, managers can choose the strategy that best fits their industry, product type, and customer expectations. That brings us to the end of this lecture. Thank you for watching this lecture on push and pull view in a supply chain. Make sure you like this video, subscribe to my channel, and share this video because knowledge is meant to be shared. Thank you and keep watching FlowEdge.